Good evening, and welcome to the Scientific Adventures of Beardman. Today we're going to start to head towards a unit on electromagnetism. But before we can get to electromagnetism, let's make sure we fully understand magnetism. Okay, well, most of you have played with magnets. They're probably all over your fridge. And you've held them together and noticed they go together certain ways and they don't other ways. You can pull them together and shoot them across the room or bring them close and they zip together. So what's going on? Well, it turns out all magnetic properties come from moving charges. And this is where we'll get later to moving charges in a wire, electromagnetism. But for now, most magnets that you've probably played with are what are called permanent magnets. And they have a magnetic field because there are electrons moving around each atom. Now, we're not going to get too much into what's going on inside the atom, but for the most part, the electrons moving around in an atom cancel out with each other. Okay? But there's certain materials where that doesn't happen. Iron being the primary one, nickel and cobalt being two other key elements that have that property. So, in those particular atoms, each atom ends up being like a little magnet. Okay? And so what happens inside a chunk of iron is you have one magnet kind of pointing one way, and as we know, you don't get the same sides of a magnet pointing to each other, but they point opposite directions. And so those atoms line up, and when you get a whole bunch of these atoms all lined up, that little chunk, usually still microscopic, is called a domain. So if I look at a paperclip and zoomed in on one little domain and could see each atom's electrons moving and recognize the magnetic field that they produced, I would see them all lined up. And when you got near the edge of that domain, they might be pointing a different direction. Well, that's why a paperclip isn't a magnet. Okay? But if that paperclip were to be put into a magnetic field, especially a strong one, well, that would kind of yank all of these electrons to kind of line up with it. Okay, and so they would all line up. And then our piece of metal would become what we'd call a temporary magnet. It'd be a magnet until everything kind of reordered in some sort of random position, which is what it's like to begin with. They're all in random positions as they kind of cancel out. But once we put them in that magnetic field, they all line up and we get a temporary magnet that you can then hold another paperclip with. Now, if we want those atoms to rearrange back to a random position, well, what can we do to make atoms move? Well, they move faster when you heat them up. So they're kind of sitting here moving anyways, but keeping it. So you heat them up and they get moving faster and they rearrange. Another way you can do it is to just make them move very physically, taking a hammer and smashing the things. Okay, you hit your paperclip, hit it hard enough, all the molecules jostle around, and sure enough, what was once all lined up becomes off to an angle. Now, if you can create a material where the atoms are really held in position fairly rigidly because of the bonding of the things around them, well, then you have to get it really hot to move them, or you have to hit it really hard a whole lot of times to get them to move so you can break those intermolecular forces, or the forces between the atoms. Okay? So, if you want your magnets to stay in good shape, not getting rearranged so that it becomes weaker, well, don't heat them up. Keep them as cool as possible. The less those atoms are jiggling, the less they'll start to reorient. Okay, and they'll stay all lined up. And that's the best way to keep your magnet kind of, strong. So, if we take a magnet, like say a bar magnet, and we take another magnet, like say a compass, where you've taken that magnet and you've allowed it to rotate, okay, and we set them near each other, we can use our compass to figure out what the magnetic field will look like. Okay? If you're in my class, we're going to do that in class tomorrow. If you're not in my class, you can look up magnetic field around a bar magnet and find some pictures on the internet. Hope you enjoy, and if you're in my class, look forward to doing some activities tomorrow with compasses and magnets and magnetic fields. Hope you enjoyed the scientific adventures of Beardman. Go play with some magnets. See you next time.